Hi, my name is Tanjiri Susan, and I'm working with Slimani in our project, which is personalized distillation for electrogastrogram signal processing to predict diabetes. And our product is called Gastro AI. As we all know, diabetes is a health issue that is growing highly on a high scale. And an early detection, non-invasive, affordable method is required for this, which is necessary, and that is exactly what we are suggesting, what we are presenting, what we are giving to you. And our project is relevant because an early detection and monitoring can significantly improve patient outcomes and reduce healthcare burdens. And our objectives are, we're mainly focusing on developing a machine learning model to process EGG signals for diabetes prediction, and also implement personalized distillation to enhance model efficiency, evaluate the model's performance using metrics like accuracy, precision, recall, and F1 score, and also demonstrate the feasibility of using ADD signals as a diagnostic tool. And our approach leverages EGG signals, an non-invasive, affordable method enhanced through personalized distillation, a technique that optimizes AI models to efficiently process EGG signals for accurate diabetes prediction. And our innovation is mainly a novel application of personalized distillation in electrogastrogram signal processing for a non-invasive diabetes prediction. And this is how it works. It collects data. We are supposed to collect data and pre-process and also select the models and train them. We evaluate evaluate the models, then deploy the models and create the user interface design. We test it and validate it, which is testing and validation, and finally deploy and monitor on the cloud. And the data sets we used are the EGG signals recorded from 25 healthy individuals and 15 diabetic individuals. There are after and before consuming a standard oatmeal. And our pre-processing, we use the sampling rate of 2 hours, 10-bit resolution, amplifier gain of 1000, a third order band pass Butterworth filter, which is between 0.03 to 0.25 hertz. And the techniques we used, or the algorithms we used are personalized distillation applied to neural networks for feature extraction and classification. And we chose this because it enhances performance by training a compact model with guidance from a larger model. For example, the student teacher model.
So we have individuals that are diabetic, and we put the three electrode prods on their stomachs. We pick their signals before and after they've eaten. Then these signals are amplified, as they are very tiny signals, so they're amplified so that it makes sense of them. Then data activation, this device stores the EEG signal. Then the models on the computers do the pre-processing, and then they manipulate, and then you can classify. So the implementation in details is Python, NumPy as the libraries, Pandas, Matplotlib, a Streamlit for the application web application, JobLib, and all that. So platforms that we used, for example, deployment, we used AWS, Google Colab for analyzing data sets, GitHub storing data repositories, and all that. Yes. And next, we have our best model. This is our best model, decision tree. As she said, we used accuracy, precision, and recall reference score to understand to evaluate the model performances. Yeah. So this is the model performance in different scenarios for first personal learning, knowledge distributions, personal legislation in those scenarios. We did all this to try to get to try to make sure that the model was robust in all conditions. This was its performance, and others were a little bit faster. That's why this was better. The only close one was XG Boost, but for it had more computational time, and the confidence of prediction was lower than this. Yeah, so next we have relevance, impact and relevance. Global relevance, we are helping remote areas have these cheap but efficient tools so that they can be able to at least also know that their diabetes status earlier, and maybe try to get help at a cheaper cost before it gets worse. It is in alignment with the good health and well-being, the SDG 3 of the World Health Organization. So targeted user, we have the healthcare practitioners, patients, and then we have researchers, insurance companies, and all that. Those are targeted users and customers here. Then intellectual property innovation, what we're putting. First, we put this novelty. This would be the application of personal distillation for EDG signals processing for diabetes prediction. Copyright automatically applies to the code, of course, then the documentation, the write-up we made. Then the patent, we might have patent for our model. We're planning to have patent for our model and the method we use to, to implement it. Then the trademark is just for AI, as we have the then monetization and scaling. Where how are we planning to get money from this? We're licensing, then subscription, then one-time payment for people that, visit the website and input their EDG signals. Market size, we might have a big market size. As of now, since there is no one having such a thing, we might have some market size for a while before someone catches up to come and be the same, have the same product. Next, we have how a system demonstration, though right now we have screenshots, but in other videos we have an actual system demonstration due to time. This app is the desktop version. Then down we have the front version. Since this thing is already hosted, you can enter the signals of before and after you open, and then you get results of your user prediction. Then team contribution, as you see, my colleague worked some bits and also worked some bits out there. Next, we have lessons learned. Technical challenges, data acquisition. Data was really hard to get, and EDG signals are not put out there because they are confidential to people's health and all that. Yeah, team challenges, EDG signal acquisition, resource availability like hosting and all that. Yeah. Then lessons, understanding of analytic distribution, then team collaborations and all that, improve skills, skills and all that. Future works, we are planning on enhancing the model accuracy and testing larger data sets because right now we have a small data set. We plan to go and acquire our own data so that we can run this model. The scalability when the system scales up, we plan to increase on the what on the resources so that this traffic can be able to work on as many people as we can next time. Real-time monitoring, we plan to make this portable so that someone can have it on a watch so that they can their status at anything. Successfully implemented personal registration, EDG signals for non-invasive diabetes prediction so that we don't have to go back to the ancient days of blood testing and knowing the glucose and all that. Yeah. Call of action, we request that we have people that maybe collaborate with us, we need mentors to put us more in direction so that we can at least have a more robust and more useful thing in the future and maybe have. So thank you. This has been group